Welcome to my walkthrough for Maths Higher GCSE from the Eduqas, sometimes called WJEC syllabus, and we're looking at the series from November 2024, and they call it Component 1. We'll know it as Paper 1, but more importantly, it's non-calc, so let's shush and get on with it. For 1A, when you're expanding brackets, yes, there's two brackets, but they're not quadratic. We don't have the situation of a bracket in front of a bracket where you would have four loops or grid if that's what you use. It's two separate questions. They're essentially a left and a right portion. Let's expand the bracket on the left. 3 times 5a gives us 15a. 3 times -2 is -6. We can now move on to the right-hand bracket. -7 multiplied by a is -7a. And be careful, -7 multiplied by -4 is positive 28. We've now got to take care of the simplifying bit. Well, let's start with 15a. Then we take away 7a, leaves you with 8a. And then totally different, we've got -6, think of it as temperature or money, whatever you prefer. If the temperature is -6, but it goes up 28 degrees, it will finish at 22 degrees. Part B, bit of logic required. How would we show whether or not a triangle is isosceles? Well, this is not a question, as you can see, about the sides. It's all about the angles. So we need to investigate whether or not two of the angles are the same. In order to find whether or not two of them are the same, we've got to just get on with it in terms of finding x. First thing we can state, angles in a triangle will add up to make 180. We need to add all our x's together. We get 19 of them. And then simplify your constants, so -9, +7, -27, all ends up as -29. You're bagging a mark for a line that's either unsimplified or not. On to the next bit, any correct bit of algebra, so for example, adding 29 to both sides gets you mark number 2. Then finding your value of x. Divide both sides by 19. It's not the worst bus stop in the world because 19 into 20 is 1 remainder 1 and 19 into 19 is 1. There you go. You've earned your third mark. You now know the value of x. You can take this value and put it in to each angle in turn and see what happens. So when you sub 11 in, bottom left, if you do 6 11s are 66, minus 9, that angle works out to be 57 degrees. The angle at the top, 5 11s plus 7 results in 62, and 8 11s are 88, minus 27 gives you 61. A mark for getting most of them, they say most, a couple of them correct, will earn you mark number 4. As you can see, they're close, but they're not. None of them are the same. It's actually a scalene triangle. You need some sort of sentence to wrap this question up. I would go with all angles are different. Hence, it's a scalene and not isosceles. I'll let you fill it in a little bit neater than I've done. On we go. When you've got to work with vectors, if you're adding, subtracting or whatever, you can just add the top elements, add the bottom elements. If you've got a number in front of a vector like that, you can just treat it as if it's brackets 3 times the top and 3 times the bottom. Now we've got the basics of some vectors out the way, let's allow BidMass to tell us that we should be adding them first. So we've got a 3 added to -1 on the top, 4 added to 2 on the bottom. You're going to pick up a mark for getting to 6 as the vector p plus q. Then let's see where we are. We have m lots of 2, 6 equals 5 and n. Which means if we look along the top, this bit, the top elements mean m times 2 must equal 5. What do we multiply by 2 to get 5? Work backwards. 5 divided by 2. And to find n, we need to do our newly discovered 2.5 times 6 gives us n. Answer 15. Part B, write down the vector r, which is parallel to vector q and is 3 times as long. In order for a vector to be 3 times as long, you just times it by 3. Think of it like moving a certain distance along and a certain distance up will give you a vector. If you repeat that process 3 times, it's really just the horizontal distance travelled and the vertical distance travelled. That means take your -1 and your 2 and treble each of them. I'm afraid it's 1 mark only, so you need both elements to be correct to get that 1 mark. Question 3. Yeah, picture of a pizza, all well and good. Loads of waffle, all well and good. The only thing which is important in the top 3 lines is it tells you there are 50 deliveries, but actually it also tells you that later on, so wasn't that important at all. Anyway, to estimate the mean when you have grouped data, you must first of all write down your midpoints. You can write them wherever you want. Some teachers will get you to write them on the left. Some teachers will call them X. Some teachers will tell you to do it down here. I don't care, as long as you know what you're doing, and as long as you've got the numbers 5, 15, 25 and 35 on your page, you're going to earn your first out of 4 marks. You then need to multiply the midpoint by the frequency again. Some teachers will call it fx or f times x. Some will get you to do it down here. Again, I don't care, as long as you've got the numbers. 5 times 10 is 50 on the page. 15 times 12, you might need to do some short multiplication or any multiplication you want, but I'll leave it up to you. Hopefully you get 180. When you do 25 times 16, I do it as 25 times 4 times 4. That's another way of timesing by 16. Then 35 times 12, same again in terms of do short multiplication if you want. Any method you choose, just make sure you agree with 420. Get those right for your second mark, but add them all up, you get 1050. You've now got 3 marks out of 4. Final step, divide by that 50. We can divide top and bottom by 10. How many 5s go into 105? Well, 5 goes into 100 20 times, and 5 goes into the 5 once. And there you go, for a pretty bog standard 4 marks. Yes, normally they are reserved for the calculator paper, but when the numbers aren't that bad, yeah, can appear on your non-calc paper, like this one's just done. Part B, calculate an estimate of the percentage that took 25 minutes or more. Let's go back to the table. All of those in that group, that's 12, took between 30 and 40 minutes, so they definitely all took 25 or more minutes. It's this group you've got to do a bit of estimating, because 25 is exactly the halfway point. So our best guess, our estimate, is that if 25 is the midpoint, then it's going to split the data into half. So it's going to be 8 above and 8 below, assuming it's evenly distributed. And that's where let's be honest, we've probably got it wrong, but it's our best guess. And that's why we use half as the estimate. So 8 in this group, giving us 20 in total. It wants it as a percentage. 20 out of the 50 deliveries is really 2/5. 1/5 as a percentage is 20%, so 2/5. 40%. Or you could have gone old school and used the formula and times it by 100, but either way is fine. Number 4, quite a strange one this. 882 as a product of primes. Now it's beyond your times table, so it is quite difficult in that respect, but if it's even, divide it by 2, and your brain's normally quite good at halving each number in turn. It's not the hardest to halve. 441. Now it's really handy if you know your square numbers as high as you can. Knowing that 441 is 21 squared will help you out a great deal here. If not, spotting that the digits of 441 add up to 9, which means it's both divisible by 3 and 9, you could have used either 3 or 9 on one of your branches, but I'm going with 21 because it splits into 7 and 3. Quite nice. Now we need to not just write it as a product. Product means must have a times, but it's prime factors, and we have indeed got them all. It wants index form. So we have a 7. There's only one of them. Sorry, there's 2 of them. My mistake. My handwriting made that look like a 2. There's 2 of them. Then we have a 3 and a 3, meaning 3 squared. And we have a 2 on its own. Now they can be in any order, but they must have the powers. You must use index form. Lose a mark if you've got 7 times 7 times 3 times 3 times 2. That answer would score 2 out of 3. And if you've not got to that point, if you've only drawn a factor tree, that's what earns you the 1 mark. On to part B. Quite a weird algebra, highest common factor, etc. question. For me, I'm going to rewrite S as a list. We've got A times A times A times B times C times C. The number T is A times A, B, 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 C, C, C. Highest common factor, if you wanted to, you could draw a little Venn diagram for these. But for me, highest common factor is what are the common prime factors. They each have a couple of A's in them, so the answer will need A squared. They both have a B in them, so that will be 1B. And they both have a couple of C's in them, C squared. If you scan across, as you can tell, that is the second one along. To find the lowest common multiple, you take the highest common factor and multiply it by whatever's left. So we have an a left over. So times by 8 means the a will go up to 8 cubed. A cubed, sorry, not 8 cubed. The b needs to be multiplied by those, b and b, taking us up to b cubed. And finally, we have a c squared that needs to be multiplied by that c, giving us c cubed, and that's the right answer. There'll be some other people who go, don't we just pick the highest power of a, highest power of b, and highest power of c when we're looking for the lowest common multiple? And yes, that's exactly right. I just think it's worth mentioning the long way and the short way. But there we go. Part C. Also quite a strange, I'd say non-standard way, but here's how I go about it. This 7 relates to that 7. So 7 times 10 to a power should be giving us 7,000. The 7 and the 7 is the obvious bit that's in common. It's really about that. And needing 3 zeros, that'd be times 10 times 10 times 10. In other words, 10 cubed, 10 to the power of 3. Same focus, except I'm not going to write it out. 6 times 10 to the q should be resulting in that 600. Well, 100 is 10 squared. So q is the power of 2. Bit more thought required for the final bit, so I will write this out. I just wanted to save a bit of room, which is why I didn't do the 600. Whoops, that's meant to be r. And it's 0.008. So when the number is written in standard form, it's really saying to you how many times has the decimal point moved. And the answer is 3 times, but when it's a small number, you need a minus power. There we go. Mark scheme, by the way, there's 3 answers, there's only 2 marks. You need all 3 correct for 2 marks, and you must get 2 correct for 1 mark. I'm afraid only getting 1 scores 0. Question 5, write down the next. Nothing too complicated, just look at what's happening to the numerator. The numerator is doubling each time. Let's carry on doubling. 1 mark for that. It's also alternating between plus and minus, so it's going to be a minus. Doesn't matter if you put your minus up there, there or there, as long as there's only one of them, they're all correct. And what's happening on the bottom? We are adding 2a each time, 9a. There we go. So a tick for the top, a tick for the bottom, but you must obviously also have a minus or you lose one of those ticks. Part B, I'd say pretty standard nth term, no quadratic nth term going on. It's going up in 6s, so 6n is part of your answer. Have a look now, compare the 6 times table to the sequence. From there to there, there to there, and so on, it's going down by 9. Job's a good one. C part I. Fibonacci means you add those 2 together, you get that. Add those 2 together, you get that, and so on. We do 8 plus 13, we get 21. We do 13 plus 21, we get 34. 21 plus 34 gives 55. That's the 8th, 9th and 10th terms. We need the next one. So it's 34 plus 59, 58, 34 plus 55, 89, only worth the 1 mark. Double I is the same principle. Let's add those two together to get the next one. Add your C's, we get 2 of them. Add your D's, we get 3 of them. It's our 5th number. Add this one to this one, add your C's. C plus 2C is 3C. 2D plus 3D is 5D. And to get your 7th number, helpful to have these written above and below, because you can add your C's together, you get 5 of them. You can add your D's together, you get 8 of them. Mark for each term being correct. Number 6. Now, some people might be lucky and know the exact conversion off the top of their head straight away they're in, but let's just explain why. If you've got a 1 centimetre by 1 centimetre square, if each dimension is in centimetres, your area would be 1 centimetre squared, but the same square written in millimetres would have an area of 100 millimetres squared, which means if you want to convert centimetres squared to millimetres, it's times by 100. If you want to convert millimetres squared to centimetres, it's divide by 100. So I'm going to go to centimetres squared. Leave that alone. Divide that by 100. We're in centimetres squared, but in order to earn the 2 marks, it's got to be fully simplified. What I've got there is a partial simplification. They're both in the 3 times table. I should be dividing left and right by 3 to get the final right answer of 5 to 1. Part B, we are making a cake. Flour, sugar, dried fruit in the ratio 5, 3, 7. 5 plus 3 plus 7 means we have 15 shares. What fraction is dried fruit? Dried fruit is mentioned third. That means dried fruit has a 7 out of 15 share. The combined mass, flour and sugar. Flour and sugar is 5 and 3, meaning 8. 8 shares are worth 560 grams. So 1 share is 70 grams, a mark. That 70 grams then needs relating to the dried fruit, which is the share of 7, 1 mark for method, 490 grams required to pick up all 3 marks. Number 7, we are playing badminton and tennis. 1 line at a time, because this is a little bit waffly. The probability that Hannah wins, 9/10. In it goes. Don't read on. Fill in the 1/10 first. The probability that Hannah wins both badminton and tennis is 9/50. So that 9/50 needs to go here. Normally they give you some data about them, but not today. We need to fill in this blank. 9/10 multiplied by a fraction is going to give 9/50. On the numerator side, 9 times 1 is 9. On the denominator side, 10 times 5 makes 50. I'll be earning a mark for that. I'll be earning another mark for 4/5. And I'll be earning my 4th mark for repeating them down on the bottom pair of branches. Part B, calculate the probability that Hannah wins one match only. That will be this pair of branches here, 9/10 times 4/5, which you could work out, but I'll do it in a sec, because there's another branch. She could lose the first game and win the second game. It's a times. As you can see, left-hand part, top times top, bottom times bottom, and top times top. Whoops, we all know that's a 5, don't we? Bottom times bottom. Final answer, 1 mark for each of those, by the way. And your final mark for adding them correctly, 37/50. And there we go. On to this one. For number 8, a little bit of setup required in that, yep, if that's 75 and that's 60, the other angle, that's 45. It is worth just taking a second just to fill the other bit of information in. So you've got the situation that all 4 triangles are definitely similar in that they have all the same angles, but not similar in that it's not in the same proportion. So they might be opposite. You've always got to be interested in the angle and the side that is opposite. So the thing with triangle B is it's kind of the odd one out. We actually don't know any of the sides. That's the one where you need more information. B, no, not enough known. But to compare the others, look at the side which is opposite. Look at the angle, which is opposite the side. If we look at triangle C is congruent to triangle D, yes it is, because the 10 is opposite the 60. That means they're in the same rotation and they follow the same order. It could be a flip over, but they follow the same order. You've got, for example, angle, side, angle. ASA is a test for congruence. When it comes to A and C, though, A, the 75 is opposite the 10. The 60 is opposite the 10. It might sound weird, but if you try to cut them both out of paper, you will not be able to flip them around, turn them over, and exactly match them up so they lie perfectly on top of each other. It just won't happen, because angle side angle is different for both. Here, for A, angle side angle is 60, 10, 45. For triangle C, angle side angle is 75, 10, 45. You're mentioning different numbers, it's a false. Okay, I must admit, not a fan of those when I was learning it in school or teaching it in school or even explaining it now. Not a fan. Anyway, on to part B. Is it possible to draw an isosceles triangle with an exterior angle of 60 degrees? Well, let's draw it. Doesn't have to be the world's greatest, but that will show you that if you have an exterior angle of 60, the interior angle would be 120. And is that possible? Well, yeah, as long as the base angles are 30 each. So it is absolutely possible. So ticking yes with some good explanation scores you 1 mark. The mark scheme needs you to have some description or visual depiction of the fact you know that the base angles would need to be 30. That's what gets you the second mark. Part C, bit of my earlier waffle in regards to what does similar mean. Similar means the angles are the same, but in terms of the sides, they can have a multiplier. So let's have a look. Let's have a look at the smallest sides. On both triangles, they're the smallest. Let's do a divide, because dividing them finds the multiplier. It's 4/3. Let's look at the biggest sides. 12 over 9, guess what? Cancels down to 4/3. It's looking good, but now they've thrown a little spanner in the works. That's 7.5. Not a problem. It's easy to get rid of. You could either times top and bottom by 10, then cancel it down. I'm going to double them. And guess what that cancels down to? Yep, 4 over 3. Show that they are mathematically similar. I would just sort of put same scale factor, hence similar. But you can write that out in full when you're having a bash. Number 8. Solid cylinder, radius 4, height h, OK. Total surface area, stop right there. As we know, it's a solid, which means it's got a lid, which is a circle, a base, which is the same sized circle, and it's got a curved surface area, which if you were to peel the label off like a soup or baked bean tin, it makes that shape. Now the area of the circles is simply 2 times pi r squared. We'll do it properly down here. It's the rectangle which people always forget. How do we find the area of this rectangle? Well, h is that distance there, but that distance here corresponds to that circumference there. So total surface area will be 2 lots of pi times the radius squared added to 2 times pi times the radius times the height, and that should equal 104 pi centimeters squared. We haven't got a calculator, so we just sort of try and make it a bit simpler each time. Firstly, let's divide every term by pi, and let's use a bit of BIDMAS over here. 2 times 4 squared is 2 times 16. Here, 2 times 4 times h, 2 4s are 8. Right hand side, 104. Should have mentioned a couple of marks for that line, another mark for getting it simplified and doing any bit of algebra. Let's now subtract 32 from both sides, and you know you're going right when it works out nice and friendly. H will be 72 divided by 8, 9 centimeters for your final mark. On we go. I'm going to do this rather untidily. Make sure you use a ruler. I'm just going to explain how you draw it. Firstly, one big no-no, by the way, is don't make your box inconsistent in its height and width, sort of like that. Different size whiskers. As you can see down here, every vertical line is the same height. So do avoid having inconsistent thickness. Here we go though. Lowest mark is 12. You need your first notch at 12. Highest mark is 40. In it goes. Lower quartile is 22, with a ruler, like I say, and median of 29 in its slots. But that 13 is not a notch. You need to do lower quartile plus the interquartile range gives you 35. You need your upper quartile marking at, 35. Grab a ruler, make it neater than mine. 3 marks. 1 mark is for working out the 35. 1 mark is for correct whiskers, and 1 mark is for the correct box. Part B, 2 box plots. There we go, chemistry and physics. Now stay on this page while I answer part I and II. Part I says, calculate the number of students that were awarded 10 or more marks in physics. There's 10. There we go. Now, quartiles do exactly what they say on the tin. They split the data into quarters. So there'll be a quarter of the data here, and 1, 2, 3 quarters of the data is up here. As you can see, it's 280 students. We need to work out 3 quarters of 280. If you do 280 divided by 4, you get 70. 70 times 3. We're done. 1 mark for 3 quarters, 1 mark for 210. Part II, oops, can't get it right. 2 teachers disagree. One teacher talks about spread, the other teacher says the spread is only and so on. Best way to solve this is with a little table. We've got biology, we've got chemistry and physics, we've got the range. In some cases we were told these. If you go back to your box and whiskers, biggest take away smallest is actually 28 for all 3. Whereas for the interquartile range, it was 13, 13 and 20. And there we go. Explain why both teachers are correct. A little sentence about range, as in same spread for all 3, and a little short sweet sentence for interquartile range. Same spread for only 2 of the tests. You've got all the numbers to back up those short statements. You'll be earning all 3 marks. Part C, loads of waffle, big table. It's only worth 1 mark. It's one of them horrible ones that's got a lot going on. Only 1 mark. Why is it wrong? Cumulative graphs should always go up. At worst, they should be horizontal. They should never have a negative gradient. They should never go down. Criticize the above graph. Make that statement. I would write cumulative should never decrease. Again, any words to that effect will pick up that 1 mark. Number 11. More waffle for very few marks. Alison lives in a town, 45,000. Prediction, increase by 2% every 6 months, and that's in bold. Must be important. For 4 years. Now there's the clue. That's in years. That's in months. Whoops. 4 years, 6 months will be 4 times 2. You actually should have a power of 8 there. That should be 1.02. They've got the multiplier correct, 2% increase, but they've got the number of 6-month periods wrong. They've put the number of years in. It's not what we're talking about. That power needs to be 8 for your first mark. Next, to decrease something by 5%, you do not divide. It's always multiply. But to decrease by 5%, your multiplier is 0.95. That's the mistake that Alison has done incorrectly. Part B, circle the sketch which represents this. Now, I don't think this is very easy, so let's do it by a process of elimination. Firstly, you can eliminate A because it's basically always on the up. There's got to be a point where it decreases. Same for E, we can eliminate that one. Next, with which one of these 3 can we eliminate? Well, as you can see in part D, it has that shape. That really means that the rate of change of increase is slowing down. That's not true. If you've got that, you would have exponential growth. The graph should be shaped like that. It would increase by more and more over time. That means we can eliminate D. As you can see though, that shape is present in both graphs B and C. It's what they do after their peak that's different. C's has that shape, which means the decrease gets more and more. That's not true. If you multiply something by 0.95 and again and again and again and again, that type of graph will have that shape. It will reduce and reduce, yes, but the amount of reduction year on year will get less and less each time. Not correct. C can be eliminated. B, therefore, is the correct answer. Gotta admit, very tough one in my opinion, for just 1 mark. At last, for number 12, bit of proper maths. Here we go. Laws of indices. When you have a number to a fractional power, I prefer to write it as the numerator makes the number bigger, the denominator makes the number smaller. And because we don't have a calculator, we do the cube root of 27 first, gives us 3. Then we can square our answer to give us 9. If you've got 3 on your page, you get a tick. Got 9 on your page, you get both ticks. Part B. 2 solid shapes are similar. Surface areas is 1 to k. In order to do it for linear, you would square root both sides. Square root of 1 is 1. Square root of k just looks like that because we can't do it. But to go for volume, each of these should be cubed, for volume is 3 dimensions. Write in terms of k an expression. Well, folks, that's the right answer. You can leave it like that. Or, if you've tidied up the 1, and maybe you've looked at part A, and you've tidied up the k to be 3/2, no one cares. It's only worth 1 mark. You've earned your 1 mark for either of them. Part C, it's a 4 mark rearranging. Going to be quite tricky. Take your time. We never like fractions when we're doing this, so get rid of that G straight away. Multiply left and right by G. If you've done that or something similar correctly, you earn one of the 4 marks. You can now either choose to gather your G's on the left-hand side or the right-hand side. I just happen to have chose the left. Take away 2WG and add 3F by doing what's called isolating the G's. Getting the G's on one side earns you 2nd mark out of 4. If you gathered them on the right hand side, it's also correct. You should just have the signs being opposite way, so it should be positive 2WG minus 5G and so on. That should obviously follow through to your final answer anyway. By isolating the G's, you can now take a G out. We've earned 3 out of 4, and we've now got G on its own if we divide both sides by the brackets. 4 marks, and if you took your G's to the other side, you should simply have different signs in front of every aspect of my answer. But it's all good. They both earn 4 marks. Number 13. So, they don't look very friendly, these, but my advice is always the same. Just because you don't know the length of X or Y or whatever, just crack on as if you do. The shape above is made from 2 rectangles, and we are interested in area. This top rectangle is 5 by 2x plus 1. Let's multiply them. 5 brackets, 2x plus 1. And this would be that times that. With it being a show question, I would definitely show that line of working out. Show the examiner where you've got things from. Those two, when expanded and so on, simplified, we would get 98. So let's do that, because that's exactly what we're being asked to show. 5 times 2x and 5 times 1. Loops or grid if you want, entirely your choice, but we get 8x squared minus 10x plus 12x minus 15, and we are attempting to rearrange so that we end up with 0 on the right hand side. So let's simplify our x squareds. We've only got one term. Let's simplify our x's. 10x, take away 10x, they disappear. We've only got 12x left. And finally, 5, take away 15 is minus 10, minus 98 from both sides, negative 108. And it looks like what we're having, except we need to divide everything by 4 and keep an eye on the target. It does indeed work a treat. Part B, 6 marks. Can't be that straightforward. Well, no, it isn't. To calculate the perimeter of the shape, we first need x. Now, I'm not going to, because when I write with this, it's much bigger. On my proper answers, where I'm writing in biro, I've done the full working out, including the AC method. For now, I'm not going to bother. Let's assume we've done the AC method. There we go. 2 of the 6 marks banked. That means x will either be 3 or x is negative 4.5, but no, it isn't. You cannot have a negative length. That gets rejected. It's 3 that we're interested in. It's 3 that we're going to use. Now you've got a choice. You can either sub the 3 in and replace all the lengths. Don't forget that that's 2x plus 1. This there is 2x plus 3. That there will be 4x minus 5. And then we've also got to take away another x from there because it's not included, and it's also 5. Take away that x, that's 5 minus x. This side here is 4x minus 5, and then we need to subtract that x as well. So it's 3x minus 5 over there. And yet, you could sub the x into all of these, add them all up. Me, I'll do the algebra. If you add together all those sides, you should get 14x. You should get plus 8. We're up to 5 out of 6. In goes the value of x. 14 times 3. Add on 8. Quite a long-winded, but yeah, 6 marks. So take your time. I've rushed it a little bit. But yeah, I'm afraid you get no marks for any of the little bit there. You just need to make sure you don't miss a side out. If you haven't got the answer 50, you've got 40 something, you've missed out one of these sides. So just take care that you include all sides. Anyway, number 14. As I mentioned, I'm doing this live and my ability with electronic pens and technology is rubbish. Do consult my work solutions and I'll show you a better line on there. But anyway, what you need to do to calculate the rate means gradient. You need to plonk a good tangent at the point where the time is 6. Try your best. That'll do, I think. That's not bad. Now, a couple of things on why I've put it there. I've put it there because it's a little bit off to the left, if I'm honest, but it's only estimate, so no one cares. But by putting my triangle at that size means I don't have to estimate its width. Its width is a dead easy value. It's from 5 to 7. It has a width of 2. Then a little bit of counting for the height. 1, 2, 3, 4, 6, 7, 8, 9.5. Let's call it 9. Okay. Now the mark scheme does not give a specific right answer here. It just says 1 mark for a good tangent drawn, 1 mark for doing vertical divided by horizontal, and getting a sensible answer. Mine is definitely sensible. I got 4.5 on the original one as well. On to part B. Calculate the average rate between t is 1 and t is 2. If we look for where t is 1, the height is 2. If we look at where t is 3, the height is there. Trace that along, I'm getting 37. So the average will be 37, take away 2, that's the difference. In other words, 35. and the difference in time is 2 seconds. We've got 35 divided by 2 for 17.5. 1 for method, 1 for answer. Part C. From time t equals 7 minutes. So as you can see, there's a bit of this graph missing. You're going to need to grab a ruler and draw it. You know where the graph's going to start, but you don't know where the graph's going to finish. That's what it's all about. So let's do that calculation. What we do know at that point is that there is 40 litres to leak out. If 40 litres is leaking out at 5/6 per second, we need to do 40 divided by 5/6 to tell us how long it will take. So this is a hidden fractions question. Let's turn the 40 into a fraction. And how do we divide by 5/6? We multiply by 6/5. Keep, flip, change. Top times top. Bottom times bottom. This does cancel. 5s does go into 240. Feel free to use bus stop method if you want, but it's 48 minutes. Now 48 minutes doesn't really correspond to this because it's got it in tenths, like so. So we need a little bit of a thinking here. 48 minutes, let's not forget, is 48/60ths of an hour. Now if we cancel that down, divide top and bottom and so on, divide top by 6, bottom by 6, it means 8 out of 10 squares. There we go. It needs to terminate at the 8th out of the 10 squares. There we go. It should be a straight line because the assumption is that it is linear because it says at a constant rate. That's why you need a ruler. No freehand, no curve. Get a ruler. Lose a mark if it's freehand or just unruled or whatever, and you get your second mark for it finishing in the correct place. To number 15. If you're looking at 15A and hoping there's a quick way of doing it, I personally wouldn't go for a quick way. If you're faced with something new like this in an exam, why not just, they've given you plenty of room, why not use it? Evaluate, so work out the value of 0.20 and recurring dots above the 4, 5, 4, 5, and so on. Now let's just say that we were going to subtract 0.003, and that would be followed by an infinite number of zeros. Nothing wrong with this way of thinking. And then all them, certainly they're all going to be 5454. That's just going to keep on going forever. What you want to look at is what's going on above that. We've got 4 minus 3. 4 take away 3 is 1. 0 take away 0. And 2 minus 0. In other words, 0.201. So that means that's gone. It's got to start 201. And after the 1, it's 5, 4 recurring. That means it has to be, oh, it just says Derek chose A. It's not A. Is he correct? No. It's definitely answer D. It's always a better way how to show someone's done something wrong do it right. Question B, a little bit non-standard this one in that it goes to 10,000x, but not a problem. Stick with the method that works. My method is, apart from calling it x, because that's everyone's method, create a bit of room so you can keep the decimal points lined up and you don't have to squeeze things in. 0.1 and it's 2, 3, 4, 2, 3, 4, 2, 3, 4. You always want to budget up, move them up, so that the recurring happens immediately after the decimal point. To budge them all up, we would need to times by 10. And then what you want is to budge them all up again, so that it's exactly the same. That would be from there to there, needs timesing by 1,000. If you multiply the left-hand side by 1,000, 10 times 1,000 is going to be 10,000x. But now you can do a giant takeaway. Oops, just need to fill in the 1, 2, 3, 4. Now you can do a giant takeaway because everything that follows the decimal point will cancel out and disappear. That means it's all gone. You've only got to worry about 1,234 minus 1. You've then got to do 10,000x, take away 10x is 9,990x. Unfortunately, it wants this in the simplest form, so you can't just leave your answer as 1233 over 9990. The obvious number for me is that they both divide by 3. Mental arithmetic or bus stop, it's entirely up to you. On the top, 1,200 divided by 3 is 400, and 3 into 33 is 11. And then divide the bottom by 3. Yep, it's nice and easy. Unfortunately, don't stop there, because look at the digits of 411. They add up to 6, which is a multiple of 3. And on the bottom, they add up to 9, which is a multiple of 3. They can both be divided by 3. Again, bus stop if you want. I've gone for mental arithmetic. 137, 1110. A very awkward question for a non-calc paper, but it is what it is. It doesn't, I will just say, we are only on question 15, but we're not far from the end, because there's a lot of questions on here worth loads of marks. You look at the cover, as you can see, there's actually only 18 questions. A lot of the time on these Eduqas papers, there's mid-20s. Not today, because a lot of them are multi-parters required and worth a lot of marks. Part C, estimate. That means get rid of that 1.9. You don't need that. It's 2. When you are raising a number to a power, you can simply split it up. Think of it as if this was algebra. If I said to you, do that, you could do 2 to the power of 5, work that out, and you'd have x cubed to the power of 5, and you add the powers. Well, that's for algebra, but same works for numbers. We need to have 2 to the power of 5, you get 1 mark for 2, and you need to do 10 cubed all to the power of 5. 2 to the power of 5 is 32, and when you add the powers, you're nearly there. Because not quite. Give your answer in standard form. We need to divide the 32 by 10 to give us that magic number between 1 and 10. But if we are dividing this by 10, we need to times this by 10 to balance it up, which means adding 1 to the power. On we go. Number 16. As you can see, we have got a non-right-angled triangle. The diagram shows that all that information is waffle because it's already on the diagram. The ratio of the area of the triangle to the area of the circle, which is circumscribing or whatever, who cares, is 7 to 16 pi. Calculate that. So there's a circle doing that really, or whatever. All right, we're not that bothered. Doesn't tell us where it is actually. Don't worry about it. Worry about the fact you've got a triangle and you've got a formula which is a half AB sine C. A half times, you've got 14 and a 15 either side of a 37-degree angle. Well, a half times 14 is 7. So we can tidy that up a little bit. And sine 37 is 0.6. I'm going to rewrite that as 3/5 for reasons which should be obvious in that the 15 and the 5 will cancel out in a sec. 7 times 15 is 105 times 3 is 300. And we should just divide by the bottom, aren't I? 105 divided by 5 is 21 times by 3 is 63. Nearly did that the long way. Anyway, 63 is the area of this triangle. Triangle to circle, it's a rubbish circle, no one cares, is 7 to 16 pi. To go from there to there, it's times by 9. And because they're in the same proportion when it's a same ratio, we should be timesing that by 9 as well. A little bit of mental arithmetic or short multiplication will tell you that 16 times 9 is 144 with a pi on the end. But you haven't finished. 144 pi, I'm afraid, is the area of the circle. It actually asks for the radius of the circle. Area of the circle is pi times the radius squared. And once you've made the pi's disappear, square root of 144 is 12. Yeah, 5 marks for that. Obviously, you're going to pick up a mark for applying that and for using it to get the 63. But then scaling the ratio to get the area, square rooting to get the radius, is where your 5 marks come from. On to some surds. Simplify, well, the left hand needs rationalising. So let's focus on the 35 over root 5 needs to be multiplied by root 5 over root 5. Top times top, bottom times bottom. 35 times root 5 is 35 root 5. Root 5 times root 5 on the bottom. There we go. The 35 over 5 becomes 35 divided by 5 becomes 7 root 5. And let's go back to the question. 7 root 5, take away root 5. 6 root 5 for your final answer. 1 for multiplying, attempting to rationalise. 1 mark for getting 7 root 5. 1 mark for realising the final answer. Part B, it's definitely looking non-standard. Well, if something's non-standard, just think, well, what can I do? Well, there's some brackets. It's a SURDS question. You should have revised or you've certainly expanded some SURDS brackets before. Do it again, and at least if you do that, you're picking up a couple of the 6 marks. We've got 5 times 4. 5 times minus a root 3 gives us minus 5a root 3. This loop is 4 times 2 root 3, so 8 root 3. And the final loop, bit awkward, it's positive times minus. We've got an a involved. Now, not only do we have a 2, we've also got root 3 times root 3, which is 3. And 2 3s make 6. So expanding those brackets correctly, you'll definitely get one of your marks. For getting the 6a, sorry, you actually get your second mark, the minus 6a. Let's include now the 40 and the b root 3, which we have ignored thus far, as well as the 18. You could simplify, but for me, straight away, let's look at the constants. Only the constants, that's the 20. This is not a constant, it's got a root 3, that's got a root 3. This is your next constant, that's minus 6a. And that's your next constant, 40. And the right hand side, we've got 18. There we go. We've set an equation up. Let's earn our 4th mark. Let's solve it. So negative 6a, you've got 18. Take away 40, take away 20. We're getting negative 42. Divide both sides by minus 6. A works out to be 7. We can then compare the root 3 terms. We've got a negative 5a root 3. Well, 5a's is now 5 7's. That's 35. We've got 8 root 3 here. Let's put that in. And we've got added to b root 3 over here. And that equals nothing because there are no surds, no root 3's on the right hand side. That means we can basically divide everything by root 3, and if we add 35 to both sides, subtract 8 from both sides, we're getting b to be 27. On we go. Final question. Inverse functions. Find the inverse function of the g of x. Let y equal the function. Rearrange it to make x the subject. Subtract 3 from both sides. And divide both sides by 2. You earn a mark for that, but in order to write it as an inverse function, you've got to flip the x's and the y's around so that your inverse function will actually read x minus 3 all over 2. Finally, part B. Given that the g of h of x, let's start with that. The g of h of x means put the h of x into g. Put this into there. So where we saw the x, we replace the x with x squared. We've now got to worry about the h of g of x. That's the other way round. Where we see x, we replace it with 2x plus 3. And as you can see, there's also a minus x squared and a plus 1. Our job is now expand brackets, collect like terms, and make it equal to 0. So let's do exactly that. 2 times x squared, that's the easy bit. To square a bracket, square the first, you get 4x squared. Square the last, you get plus 9. And you'd have repeated x's in the middle. You'd have 2x times 3 and 3 times 2x. And again, don't forget, minus x squared plus 1. Let's collect like terms on the left. Well, there's nothing to do. And on the right, there's our x terms. Whoops, sorry. Forgot about the minus x squared. Because we've got 4x squared. Take away 1x squared. Leaves us with 3 of them. We've then got 12x in total. And we have plus 10. To make it equal to 0, we need to subtract 2x from both sides, keeping one eye on the answer. We then leave the 12x alone because there's no others, subtract 3 from both sides, and we are indeed done. And there we go, paper ticked. So, unlike a lot of Eduqas papers, normally there's 25 or so questions per paper. This one wasn't like that. There were a lot of early questions that went parts A, B, C, 2 marks, 3 marks. You can see, unusually for Eduqas papers, there's a lot of marks there, like 7, 7, 7, 7, 9, 10, 7, 8. Big markers, fewer questions. But just because it's part A, part B, doesn't mean it's any different than normal. There really were about 25 proper questions in there. It's just they disguised a few as multi-parters. But anyway, some tricky questions. Yep, as always, not as many wordy questions as we're expecting for normal Eduqas. So overall, could have been worse for a paper. Hope it's helped to work through. Not a bad paper overall. Might just see you on the next one. Cheers.